problem number 57, it says an old light bulb draws 50 watts instead of 60 due to evaporation of the thinning of the filament. This is kind of an interesting problem. I don't know how the answer goes. Gonna do it live. By what factor is its diameter reduced, assuming uniform thinning along its length and no change in temperature? So here is a light bulb. This is the kind they're talking about. The current comes through here into this very thin filament. The filament gets so hot that it glows, but it also can evaporate, especially in the low density atmosphere inside of the bulb. And so the first question you may think, why would the resistance decrease? Why would the power decrease with a thinner bulb, a thinner filament? So we know a couple things. One, remember that the resistance is the resistivity times the length over the area. So if the diameter gets smaller and the area gets smaller, then the resistance increases. What happens to the power as the resistance increases? So power is I times V. Remember that. And we're going to assume we hook this to a constant power supply. So V is constant. Well, what happens to I? I don't know. Well, it's going to change. Let's use V equals IR. And I'm going to put in I as V over R. So this is going to give me V squared over R to the power. So that means that if the resistance increases, I'm going to have less power. And that is indeed what we're having here. So the voltage is the same, but the resistance changes. Okay, so let's just do a ratio of resistances first. So I can say here, P1 is 60, and that's going to be equal to V squared over R1. And then P2 is 50, and that's the same voltage divided by R2. Now, let's take that first one up there and solve for V squared. So I get V squared equals 60 times R1. I can put that in up here. I get 50 equals 60 R1 over R2. So now I have a ratio of R1 to R2. So I can say, I'm trying to find what did it ask for? What factor is the diameter reduced? So let's solve for R1 over, let's solve for R2 over R1. So if I solve this for R2 over R1, I get R2 over R1, just multiplying by R2 over R1 divided by 50 is 60 over 50. Okay, so I know the resistance is going to increase by 6/5, or be 6/5 the initial resistance. But I want to get that in terms of diameter. So let's just use this up here. They're the same resistivity, the same length, they have different areas. And instead of the area, I want it in terms of the diameter. So I can write this as rho times L over pi d over 2 squared. That's the area, right? And that's going to be equal to d squared over 4. So I can write this as R rho L over pi d squared, I caught it, times 4 on the top. Now, the key thing here, constant, 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 constant. So this is just, I'm going to call it k over d squared, where k is just some constant. So that means that R1 is k over d1 squared, R2 is k over d2 squared. Now I can put those in over here, and I get R2 is this, so it's k over d2 squared. R1 is this, so it's going to be k d1 squared. The k is canceled. And I want the ratio of the diameters. I guess I did do it backwards. It says, by what factor is the diameter reduced? That's kind of a weird way of saying it. Well, that's fine. We can take the inverse again. So I get, do I have room right here? I'll put it up here. I have to work my board manually. that's one of my weak areas. So if I can take the square root of both sides and invert it, I get d2 over d1 is equal to the square root of 5 over 6. And that's my answer. So let's just put that in there as a number. So I have 5, 6 divided by square root 0.91. So it's 0.91 diameter of the original filament. Kind of a fun problem. Don't you think it's a little fun?